All right, seventh period. These are the other progress check questions that I thought about looking at today. I knew we wouldn't get to them all, but I thought these might be good to see an explanation from me. So I'm going to go ahead and go over these, and this may help you as you study for your test tomorrow. My son's in the background. Do I need to block him? Anyway, so this is number two from Unit 2, Progress Check A. And this is a calculator problem, and I wanted to do this one just to remind you how to use the calculators to evaluate derivatives. We have a table of values for a function, and then we also have the equation of the function right here. And they ask you to use the table values to approximate f prime of 0.5. And so the approximation, f prime of 0.5, is going to be the average rate of change from from 1 to 0. So that'd be f of 1 minus f of 0 over 1 minus 0, which ends up being 2 minus 1 over 1 minus 0, and that ends up being 1. So the approximation value is 1. But then the question is, what is the difference between the approximation and the actual value? And this is where the calculator comes into play, because when you are evaluating a derivative, you're expected to take advantage of calculator features. And so instead of actually differentiating this, which by the way, you should be able to differentiate this, it's a chain rule, the derivative would be 2 to the x cubed times the natural log of 2 and then times the derivative of the exponent. So while you should be able to do that derivative, we are going to use the derivative at a point command in the calculator. And so I'm going to show you how to do this on the Inspire and on Desmos. So first with Desmos, what I'm going to do first is I'm actually going to define the function. So my function f of x, and I literally type it in, 2 to the power of, and I do shift 6 to open up that exponent, and the exponent was x cubed. And so I simply define the function as 2 to the x cubed. I really don't care about the graph. It'll display automatically, but I'm not even looking at the graph. And if I want f prime of, what was it, f prime of 1? F prime of 0.5. If I want f prime of 0.5, you literally just type in f prime of 0.5, and there is your answer. So the approximation value is 0.5669. 0.5 and 669 would round to 67. 67. And then the difference, you would simply subtract those. So for the answer, you do 1 minus 0.567, which ends up being 0.433 for the final answer. Now, if you want to use the Inspires to get that value, I'm going to do kind of the same thing. I'm going to define the function in my calculator. So in my calculator screen, I'm going to type f of x, and then I'm going to get that out of the way. And then to store the function, above this button right next to the 9 is a colon equals. I'm going to hit control and colon equals, and then you simply type in the equation. So it's 2 to the power of x to the power of 3. So that's 2 to the x cubed. So now my function f of x is stored. And then to compute the derivative, I'll go menu, calculus, numerical derivative at a point. For me, it's option 1. If you have a CAS-capable calculator, it's going to be option 2. But you want to choose derivative at a point. The calculator will ask you what variable you want to use. I always stick with x. I want to plug in the x coordinate of 0.5 into the first derivative, and I'll click OK. And now we simply type in the equation, which I have stored for f of x. Now, I probably didn't need to store it for f of x because that's a really clean equation. It's easy to type in anyway, but I wanted to show you how to store things for in the calculator as functions, and then you can see the answer is 0.5669, the same thing that Desmos gave us, and then you could repeat the subtraction to get the difference between the approximation and the actual value. Let's go on. I want to look at number 5, and this is from Progress Check B on Unit 2. And it says, g is this ugly function, and then I skip to the end. Sometimes it's good to read questions from back to forward, and it asks for the instantaneous rate of change of g at pi over 3. In other words, what is g prime of pi over 3? And to get g prime of pi over 3, I need to first find g prime of x. And if I want g prime of x, I need to know what g of x is, and that's where this question gets really tricky because g of x is defined as a limit, but this limit is the limit definition of a derivative, and that limit is actually referring to the derivative of the function sine x. And so what is the derivative of sine x? Well, that would be cosine x. And if that's the answer to the limit, if the limit takes you to cosine x, well, that is what g of x is. And so g of x is cosine x. That means g prime of x, going back to this question, would be the negative sine of x. And then g prime of pi over 3 goes back to the unit circle, which you should know. This is a non-calculator question. So the negative sine of pi over 3 is up here at 60 degrees, and the coordinates are 1/2 root 3 over 2. So sine of pi over 3 is root 3 over 2, and the negative just comes along with it. So there is a quick explanation of number 5 from Progress Check B. I honestly can't remember what numbers I chose after that. So this is number 7 from the same Progress Check. So we have a function f. They have this weird little b of x or b times x in here, which sometimes throws people off. They do tell you b is a constant. G is some function. They give you g of 2, g prime of 2. They ask you for what value. Here's the question: for what value of b is f prime equal to 0? And so I see an f prime, and if I want to set this equal to 0, I need to find an expression for f prime of x first. So f prime of x is, let's see, well, that's going to be a product rule. I have this polynomial times g of x, and so I'll product rule that function to get f prime, so that's 3x squared plus the derivative of b times x, if b is a constant. The derivative of bx is b. The derivative of 6 is 0, so that's the derivative of the first term times the second, plus now I will leave the first term alone, not 2b, bx plus 6. And then the derivative of g is g prime of x. And now I will plug in 2. F prime of 2 is going to be 3 times 2 squared, that's 12, plus b times g of 2 plus 8 plus now 2b, b times 2, plus 6 times g prime of 2. And then they gave me values of g of 3 and g of 2 and g prime of 2. So that's 12 plus b times g of 2, which is 3, plus, I'm going to go ahead and add the 8 and the 6. That'll be 14 plus 2b, or not 2b. And g prime of negative 2, or g prime of 2 is negative 1. And I need that whole thing to equal 0. So the question is, what does b need to be so that this is 0? So when we solve the equation, 36 plus 3b, distribute that 3, distribute the negative 1. And I get b, 3b minus 2b, 36 minus 14 is 22, equals 0. And I'm getting b equals negative 22. I guess that's right. I may have made a mistake in that. I'm not sure. I don't have the options visible right now. I just got the questions. So there's my number 7. See, number 2, and now I'm on Unit 3 Progress Check. And this is a simple one. It's just asking which of the following is the chain rule an appropriate method to find the derivative. Now, this is kind of an objective or subjective question. Number 1, or option 1, you absolutely need the chain rule. You are not getting that derivative without a chain rule because we have something ugly inside the sine function. Number 2, this one is more of a product rule. It's e to the x times tangent x, and that's a product, and neither one of those require knowledge of the chain rule in order to differentiate it. You can just use your memorized derivatives for e to the x and tangent x to execute the product rule, so we will not use chain rule on number 2. And number 3 is the one that's kind of iffy, because it says for which one is the chain rule an appropriate method. And you can use the chain rule with number 3, and I would even argue that it's the better option. The quotient rule is an option because that is a quotient. However, the numerator is just a constant, so I think it's easier to differentiate this if you bring that denominator up to the top, raise it to the negative 1, and then chain rule it with the inside of 8x to the 4th minus 2x, rather than doing the quotient rule. The chain rule in this case is a little bit more efficient than doing the quotient rule. So I think 1 and 3 are the right answers for this one, and I'm pretty sure that the College Board agrees with my assessment on that one. Let's see, what else do we have? Number 3 from the Unit 3 Progress Check. F is differentiable. Which of the following, it says it gives a correct process, but it basically just says which of the following is h prime of x. And so if we were to do h prime, I see ugly stuff squared, so this is a chain rule. So I'm going to start by ignoring what I just drew that box around, and the derivative of stuff squared is 2 times the stuff. And so I'll just copy the 1 plus f of 3x down. And if you want to write that to the first power, you can. Now we need to multiply by the derivative of the inside. The derivative of 1 is 0, plus, and then the derivative of f of 3x, that itself is a chain because I have something inside the f function that we need to ignore. So we'll do the derivative of f first. That'd be f prime. We leave the 3x alone, and then we will multiply that by the derivative of the inside, and the derivative of 3x is 3. The 0 plus obviously does not have to be there. The answer choice, I believe, I remember glancing at the answer choices when I grabbed this one earlier today, and I believe the answer is something like this in one of the 4 options. So there's number 3 from Unit 3. Let's see, what else do we have? Number 6, holy cow, the curve, the point negative 2, 4 lies on that curve. F is differentiable, function of x, g is differentiable function of y. They give me values of f prime and g prime in the table above, and they want the value of dy dx. So we need to differentiate this guy. And so I'm going to look up here at this equation, and I need to find the derivative of that whole equation. And starting on the left side, I see a product rule. So the derivative of f of x would be f prime of x. I will leave the g of y alone. Plus, now I'm going to leave the f of x alone, and the derivative of g of y is g prime of y. However, that is a y term, and so I need to multiply by the derivative of y, so times dy dx equals, and the right side, the derivative of 17 is 0, the derivative of negative x is negative 1, the derivative of negative y is negative dy dx. And then they're asking us for the value of the derivative at the point negative 2, 4. So we're going to plug in the point negative 2 for x and 4 for y. And that will give me f prime of negative 2 times g of y, which is 4, plus f of negative 2, g prime of 4 times dy dx equals negative 1 minus dy dx. And now I can plug in these values up here. F prime is 4, g of 4 is 5, plus f prime of negative 2 is 3, g prime of 4 is 2, dy dx, which I'm going to change to a y prime, equals negative 1 minus dy dx, which I'm going to write as y prime. So we have 20 plus 6y prime equals negative 1 minus y prime. I will, let's see, add my y prime over, so I'll have 7 y primes on the left side. I'll subtract the 20 and divide by 3, and we get the value of the derivative to be, divide by 7, and we get the value of the derivative to be negative 3 for that one. Let's see, onward. I think so. Let's see, number 7. See, the graph of a decreasing differentiable function f is shown. Also shown is the line tangent to f at 4, 6. G is the inverse of f. G is the inverse of f. I'm going to translate that because that can be written as G is the inverse of f. And then I am seeing questions and statements about g prime of x, and so here comes that inverse derivative thing that we really didn't have much time to hammer home, all because of that stupid power outage. We did what we could Friday, but the formula for the derivative of an inverse is 1 over f prime of f inverse of x, and this question is asking about the value of g prime of 4 and g prime of 6. So let's work both of those out and see what we can figure out. So g prime of 4 is 1 over f prime of f inverse of 4. And then g prime of 6, which I'll do in blue, is going to be 1 over f prime of f inverse of 6. And to answer both of these, we need to know what f inverse of 4 and f inverse of 6 is. And so let's start with f inverse of 4. If I want f inverse of 4, I need to know when does f of x equal 4. And f of x is equal to 4 when f has a y coordinate of 4, and f appears to have a y coordinate of 4 right there. It looks like when x is 9, f has a y coordinate of 4, which means f inverse of 4 is 9, f prime of 9. And then the problem I'm going to have here is f prime of 9. I would need to know what the slope of the function is right there at that point, and I can't get that. I don't have information in this graph to be able to know for sure what that slope is. So I'm kind of abandoning the g prime of 4. I think it's going to be g prime of 6 is going to be one of the right answers. And so over here, I need to know when f of x is equal to 6, and I can look over here, and we actually have a nice clean point right here. F of 4 is equal to 6, therefore f inverse of 6 is equal to 4, and so now I can put that in here, 1 over f prime of, and f inverse of 6 is 4, and f prime of 4 is the slope of the curve at 4, which they conveniently gave us that tangent line, and the slope of this tangent line would be f prime of 4, and so I'm simply going to find two nice, clean, sexy points. There's one right there that this graph goes through, and I can count rise. We drop 3, and we run 4, so that slope is negative 3/4, and so the answer is 1 over negative 3/4, which is negative 4/3, so g prime of 6 ends up being negative 4/3, and there is your answer for number 7. Let's see, how many more do I have? Only one more. All right, last one. The derivative of inverse sine x at x equals 1/2. And y'all, you need to know your inverse trig derivatives. You need to know those. And the derivative of inverse sine x is 1 over the square root of 1 minus x squared. And I want to plug in 1/2 to that. So at x equals 1/2, we would have 1 over the square root of 1 minus 1/2 squared. And if memory serves me correct, the answers on the progress check in AP Classroom actually look like that. They didn't do any simplifying or cleaning up to it. So I just wanted to show you one inverse trig. I'm kind of upset that they didn't make this a chain rule or anything like that. Because like just for example, by the way, that's it for this one. I'm going to tweak this just a little bit, and I'm going to change it just to show you what you would do if it was a chain rule. So let's just say instead of inverse sine of x, let's say we're inverse sine of 3x. So I'm going to make that a 3x instead of just an x. Now, I'm still thinking about my memorized derivative for inverse sine. There we go. And the memorized derivative is 1 over the square root of 1 minus x squared. But instead of an x, now we have a 3x, so we would replace the x with a 3x. So the derivative is 1 over the square root of 1 minus 3x squared. But then it's a chain rule, because I now need to multiply by the derivative of what's inside my inverse trig. And so that's the derivative of inverse sine, but now we multiply it by a 3. Then we would plug in x equals 1/2, which would end up being, what, 3 over the square root of 1 minus, and 3 times 1/2 is 3/2 squared. And so there's an application of the chain rule with your inverse trig derivatives, and you do need to know those inverse trig derivatives. So you can find them you can just Google them, or if you go to my calendar, I did link on my calendar, I can leave that site. If you go to my calendar entry for last Friday, and I mentioned this in class today, if you go to the class recording, that's not it. If you go to the class recordings right here, click on 7th period, and this is actually the recording from the 8th period class when I covered the inverse trig derivatives and the inverse derivatives with BC, and you can see me going over the inverse derivatives sheet. I'm kind of skipping through it, and then right there at the 16.5 mark, you will see all the formulas for the inverse trig derivatives. And I'll spend a few minutes talking about patterns and things that can help you remember those 6 derivatives. So hopefully this video helps you a little bit if you're studying and you had some questions about some of those trickier progress check questions. So 20 minutes, I guess that's not too bad. Good luck studying, and I'll see you all tomorrow.